Have you ever wondered how round objects travel through the air with different curvatures and speeds? Hello, my name is Nathan Wallace, and today I'm going to introduce you to the concept of the Magnus effect. The Magnus effect, or Magnus force, was named after the physicist Heinrich Gustav Magnus. You may notice this effect when you throw a ball or drop a ball from a high distance. Then as it falls, you notice the ball spinning faster and faster, then appearing as if it is flying forward. It is believed that Heinrich Gustav Magnus was a great teacher. He was able to stimulate and motivate his students, which caused his rapid success. He was able to demonstrate the importance of applied science and held colleagues on physical questions at his own house. Magnus owned his laboratory privately. However, it was not integrated into the University of Berlin, and it became known as one of the best equipped in Europe. Beneficiaries of his lab include Hermann Helmholtz. Tabia Tights of the SciHiScienceBlog.org states that it is responsive to the curve of a served tennis ball or a golf ball driven and affects the trajectory of a spinning artillery shell. So what she is basically explaining is if you were to hit a golf ball with the proper amount of force and the correct amount of backspin, the ball is proven to travel further and carry more wind under it, therefore having a longer travel distance. As you can see in this picture, the rotation of the round object assists the distance of travel for the ball. Another factor that contributes to the Magnus effect is the pattern on a ball or the dimples and curves that it has in it. For example, if a golf ball were to have the dimples that it doesn't usually have, the ball would have a staggered path of trajectory. But with the normal patterns of dimples it has across the whole ball, it should have an exaggerated spin rate along with a further distance of travel whenever you hit it with the correct amount of force. There are many examples of the Magnus force in action. One of those famous examples is a curveball. It may not be as interesting as dropping a basketball from 200 feet in the air, but it demonstrates that even the simplest of curves can affect where the ball will travel. Here is a video that properly demonstrates how the Magnus effect works.
Recently, some friends of mine went to the Gordon Dam in Tasmania, which is 126.5 meters or 415 feet high. Then they dropped a basketball over the edge. You can see that the basketball gets pushed around a bit by the breeze, but it lands basically right below where it was dropped. Now watch what happens when they drop another basketball, but this time with a bit of backspin.
Whoa, look at that go! That's incredible.
The Magnus effect even dates back to the Civil War. Most of the bullets were round and didn't have any indents or ripples on them to make them any more aerodynamic or accurate. They would just fly through the air, moving staggeredly and hitting whoever they could hit. Seattle University states that a spinning object in motion exerts a net force on the air, which according to Newton's third law exerts an equal and opposite force back on the moving, spinning object, altering its trajectory. And air gets dragged along with the direction of motion, experiencing an upwards force. You may ask, why is this important or valid? My answer is, it is one of the most interesting studies to ever come across people. Even as younger kids, we've always seen somebody hit a golf ball or somebody throw something and watch it travel through the air, whether there was no wind or strong wind. And what most people can find interesting about this is that science is all around it. There is almost no single factor of it that doesn't include science or anything to do with the rotation of the ball. A fun little activity you can do to test out the Magnus effect is get a piece of paper, tape the bottom and top together, and drop it from about 8 feet in the air. Give it a backspin and you will see the Magnus effect in play. It is very interesting and I recommend it. So basically we went over what the Magnus effect applies to and also what sports involve the Magnus effect, such as tennis, golf, baseball, and basketball. We also went over Heinrich Gustav Magnus and his history of being a well-known physicist and a great teacher. It is a great thing to always experiment and wonder in life what else could possibly happen. Studies and experiments like these don't fall short in the interesting category. Thank you so much for your time and enjoy the experience of the Magnus effect.